Hi folks, Mr. Long here. I'm just going to go over your work on the ambiguous case. Specifically, just kind of give you an overview of the handout. And this starts on page 2 of the handout on the ambiguous case. So with all of these questions, we're always solving when we're given information that is in the form of side, followed by angle, right? Side, and angle here, okay, and in sequence. And so no matter what I'd like you to do is take the triangle and orientate it in the same way every time, with the angle at the left, followed by side, and with the bottom side of the triangle being your unknown. If you orientate things consistently that way, you won't have as much trouble in terms of solving it. So what we did here is we're setting it up for the cosine law, and I know I've gone through this in class, but I thought I would just do a quick overview here. And if we do that, we're going to see this right here as our contained angle, the 26. So in terms of the formula, right, you've got to have your two contained sides first, and that would be right here, right? There's your 12 squared, there's your x squared, and they contain the 26-degree angle, minus 2 times 12 times x, and then multiplied by cos of 26. And then, of course, the whole thing is set equal to the side opposite the contained angle squared. So all that's done is I've just substituted into the formula, and then in the next step I've simplified, right? I've done cos 26 times 2 times 12, and that's multiplied by x. And then I subtract 64 on both sides to set the left side equal to 0, simplified. And then this part here, folks, is the quadratic formula. So please remember, pause this at any time. That just kind of gives you a very quick overview. So you're going to have to use the quadratic formula or the solver on your calculator. I mean, obviously, when this is on a test or an exam, you're going to have to show work for the quadratic formula. So just to go over what your two solutions are, and this is the most obvious solution here. If you do get a second triangle, then you can have this scenario, right, as well. Maintaining the 26-degree angle, but also maintaining the sides at 8 and 12. So you can see where that triangle is totally different than the triangle over here to the right. So if you think about it, that triangle and that triangle all start with the same information. And the rationale, the reason is that these two angles here, the angle right there and the angle right there, have the same sine ratios, right? So since they have the same sine ratios, you'll generate two different triangles for one angle, for one sine ratio. Okay, so that's how you do that. By the way, the CAM means angle C ambiguous. Side AM means side A ambiguous. So those are your two triangles. All right, and so that is the example that's been done there is in fact example 1. So that's triangle 1, side B, side C, and angle C. And then these are your two answers. So what you should do now is just go through, draw your orientations the same way, and for all of the rest of the questions below, there's going to be two triangles. So again, same thing, you're going to substitute, draw your triangle, substitute into the cosine law, solve the quadratic equation, and then you'll figure out what the two triangles look like. I'll make sure you always draw both triangles as well when you're working down here. The next page is, it says day 2. Now this is, I'm away today, so I just wanted to make sure that you had this as well. So what I want you to do, remember, every time you get side-side angle, you may get a picture like this. You may get a picture like this, or you may get a picture like this. If you notice, they all have the exact same information. Side, side, angle. Side, side, angle. Side, side, angle. And so again, and what is the sequence? What side is it? Well, the 12 followed by the 15 followed by the angle. 12 followed by 15 followed by the angle. 12 followed by the 15 followed by the angle. So it's the same sequence as well. What I want you to do, no matter the orientation, I want you to rearrange your triangle when you're in a question and orientate it this way. So the given angle is in the bottom left vertex, or at the bottom left vertex. There's your side opposite the angle, and then your other given side is sloping up to the left, on the left half of the triangle. And if you do that and you use the cosine law, you'll notice you get the same equation every time, no matter the orientation. It's just that if you use orientation number 3 of the triangle, you're going to find it a lot easier to get a solution. So what you've got here, folks, are some examples where you can actually redraw the triangle. And again, so if this was the diagram that was given right here, you see that you do have, in fact, side, side, and angle. And so again, what I want you to do is bottom left, there's your opposite side, stays the same as 12, but I want you to move that 10 to up above, right? And it's still, again, what's your sequence? 12, 12, 30 degrees. Or sorry, 12, 10, 12, 10, 30 degrees. 12, 10, 30 degrees. The sequence is still there for side, side, angle. So you would redraw. Same thing, here's a question here. Side, side, followed by angle. So 18, 15, then angle. Redraw your triangle with angle here, and then it's 18, 15. 18, 15, 75. 18, 15, 75. As long as the sequence is the same. Okay, as you redraw, you want to always redraw. Okay, and then this is the same here. So your ambiguous case conclusions are right there. So what I'd like you to do now is to go through and do these. So the first one, it tells you there's 2 triangles, right? There's triangle 2, and there's your angles. So you're going to work through and solve the entire triangle. You always solve, or use, if you please, use the cosine law to get what is side C, I believe, because you want to figure out. Oh no, sorry. Let me move that. Let me move that to right there. So again, though, your orientation is always going to be the same. So for this first triangle right here, remember, just pause and rewind too. So for this one, you're going to have the same, it's always the same, right? The same orientation. So you have a 42-degree angle. What's opposite that 42? So 42 is angle A, so side A is going to be opposite. It's 12, and that's 17. Well, it looks like that 12 can perhaps swing over and maintain the same 12, right? And you'll have an ambiguous triangle, which you do. There's 2 triangles. Now, what's different about this one? Well, the opposite side is longer. So there's angle A and there's side A. So since that 26 is longer than 20, you can only get 1 triangle. And we did a summary of why that was in class. So that's really important. So this one here, again, you put it, well, by the way, with this one here, if you try that one, if you try this one here in the cosine law, which I would encourage you to do, you're going to get one solution which is positive and another solution which is negative. Well, obviously the negative solution doesn't make sense. You don't have a negative length of a triangle, so you do only have 1 triangle. Here you're going to, and this one here, you've got one of these scenarios, right? You've got one of those scenarios where this side here, the side A, which is 5, isn't long enough to touch the base, so you don't even have a triangle. So notice, do the discriminant in this case, and I think you're going to get a negative. And the same thing here, you'll do this one here as well. Okay, and now you're going to get two triangles again. So here, one triangle. My guess is if there's one triangle in the solution that you start from this information here. So you've got side A is 13. Okay, so this side is much longer. So that's 13, that's 24, and that's 10. Well, you can't possibly get two triangles here because if you look at that 13, if it comes over here, it has to be, keep the 13, it can't be the same. You can't get two triangles, right? If you want to have a length of 13 here, it goes right past the base. So it's not possible. Okay, so you can't get two triangles here. If the opposite side is longer than one of the containing sides, you'll only get one triangle. So this is where you're going to get a positive and negative result from the discriminant. Okay, number 6. You're going to do number 6. Sorry, you'll do number 6 as well. So I want you to do those. Questions, and this is. I don't want to tell you too much, but think about it. The discriminant is really close to 0. There's only one solution, which means there is only one triangle. And then what type of a triangle does that have to be? Okay, I hope this helped. This summary helped. You want to just work through and finish all the pages in this package for the start of our next class day together.